So we're dealing with section 4.2, part 2. And here we're going to be talking about graphs and transformations of logs. Remember, logs are the inverses of exponentials. So if you remember, if we had an exponential, they all went through 0, 1. And then this was if this was 1, this would be our base. So they're all going to go through there. And the exponential will look like this. Well, sort of. Okay, so there's my exponential. Okay. The thing to remember is inverses are a reflection through y equals x. Or we're going to take some xy values and put them out. So let's take a look at this guy. 0, 1, right? It will come and it will actually plot at 1, 0. Okay, remember you switch your x and y. So if I had 0, 1, I plot that at 1, 0. Okay, and then I had a point here, which was 1 and my base. So I'm going to plot that as my base, whatever that is, and 1. So if you go to x equals 1, you should be able to read your base. And now if we graph these things, if you take a look, you'll see they're going to look like this. Okay, the domain of an exponential. Domain. Take a look at this guy was all real numbers. My range, y is greater than 0. So for a logarithmic, since these are switched around, since we swap my x and y's, we should also swap domain and range, and that is indeed what happens. So if you take a look at it, you'll see that this is my vertical asymptote now. It's approaching it. So x is going to be bigger than 0. And my range now is going to be all real numbers. Okay, let's find domain and range of a function. So let's find domain and range of log of x plus 3. So what this means is this thing has been shifted left 3 units. So what I do, then let's graph our parent function for a log, which is going to look like this. And I'm just going to move everything 3 units to the left, which means that my vertical asymptote no longer is at x equals 0. It's going to be at x equals negative 3. And then when I redraw this one, and this point here, which was 1, 0, I move it over, it's going to be right there. It's going to look like this. Now we need to find domain and range. So domain. Now you notice we moved this over now, so instead of being bigger than 0, x is going to be all values bigger than negative 3. For my range, I'm still dealing with all real numbers. Okay, let's take a look at a strange little puppy. I want to find domain and range of log base 3 of x squared minus 1. Okay, so let's come back in and take a look at this again. Now, one thing you'll notice is that this stuff inside here, so the argument, which is what this is called, the argument into the log, or the stuff that's inside the log, has to be bigger than 0. It can't be equal to or less than 0. It has to be bigger than 0. So let's come over here and take a look at this. So we want this to be bigger than 0. So the first thing I always do is factor this. And I've got two guys in here. So I know I'm going to have two vertical asymptotes because my vertical asymptotes occur with what make these 0. They're going to be at x equals to plus or minus 1. They're going to be what's going to make these two 0. So to find my domain and range now in this thing, I'm going to come in and I'm going to go ahead and draw my asymptotes. Okay, this is a parabola, that's true. But the trouble is we don't really know what is and what is not inside of my thing. So you can do this two ways. Either take a look at this and figure out what will make this bigger than 0, or a better way to do this is to pick test points. And I've got 3 points, 3 intervals right here. So the first test point I'm going to pick is 0. Well, that's nice. I can plug it in. So x squared minus 1. So now I'm going to have 0 squared minus 1, which is negative 1. Since that is less than 0, this is not in domain. Okay, now I know these things are going to be going down here and here because of what I've got. So now let's come in and let's pick a point over here, like 2, negative 2. Negative 2 squared minus 1 is going to be bigger than 0. So this is in domain. And also pick a point over here, 2. 2 squared minus 1 is going to be bigger than 0. So this also is. So what this guy looks like is it's going to come up. It's going to go through these points here and bounce out. And that's what this guy looks like with my two vertical asymptotes. These points are not in my domain. So my domain then will be negative infinity to negative 1, but we don't include it. Union with 1 to infinity. X is not between or equal to negative 1 and 1. Okay, so to find our local, the other thing you need to do is finding local max and min. Graph and look for highs and lows. Not everything is going to have a maximum or a minimum. Let's come back in and take a look at this guy. We've got our graph. You'll notice on this one we don't have either a maximum or a minimum anywhere in here. There's no maximum or minimum here or maximum or minimum here. Again, the same idea here. We have no local maximum minimum on our base guy. So graph and take a look and see if there are any bumps. So for instance, if your graph looks something like this, and believe it or not, you can get something like this out of logarithmic. This is a maximum. Or if it looks something like this is a maximum. Or if it looks something like that, this is a minimum value.